This is Stephanie from statisticshowto.com, and in this video I'm going to be showing you about the variance of the sampling distribution of the sample mean. I'm going to work through a sample problem to find the variance of the sampling distribution of the sample mean, and I'll also be showing you why it works and what exactly the variance means when you're referring to the sampling distribution of the sample mean. The formula for the variance of the sampling distribution of the sampling mean, and we write it like this with a sub m, this is the variance of the sampling distribution of the sample mean, is equal to the population variance, that's just the standard deviation squared, divided by the number of items in your sample. Let's say we had a population with a standard deviation of, say, 20 and a sample size n of 19. We can use this formula up here to figure out our variance of the sampling distribution of the sample mean. So this is going to equal our standard deviation squared, 20 squared, all over n, our sample size is 19, which is going to equal 400 divided by 19, which is equal to about 21.05. This is our variance, and if you've studied variance in statistics, this number doesn't actually give you a concrete piece of information about much, but a variance of 21 means that there is a variance in the means. The larger your sample size, the closer this variance will get to zero, and that means that your probability distribution of the means is actually representative of the actual population. Let me show you exactly what I mean by that. This is a probability distribution for the sample mean, and as you can see there's a couple hundred samples that have been drawn. Each of these crosses marks one sample, and the mean for the population is 6. And when we draw our sample means and we find out what the average is, the bulk of the averages from our samples are going to be around 6. But as you can see, there's quite a lot of variance here. It could be just above 6 or it could be just below 6. The idea is we want to continue to draw samples, as many as possible. Central limit theorem tells us that the more samples we draw, the closer we are to the actual mean in our sampling distribution. The larger the sample size, the smaller the variance. Now why is that? Let's take a look at the formula again. In the formula we're dividing by the sample size, so the larger this denominator gets, the smaller the variance of the sampling distribution will get. Let me show you how this works with a quick example. We calculated just a second ago that if we had a sample size of 19, then 400 divided by 19 is 21.05. What if we increase this sample size? What is going to happen to our variance? If we increase our sample size to 400, our variance is going to equal 1, which is significantly smaller than 21.05. If we went all the way up to, say, 10,000, so now we've got 400 divided by 10,000, our variance is going to be 0.04. In other words, if we draw 10,000 samples, our variance is small and our sample mean is going to be extremely close to the actual mean for the population. I'm going to show you one more example of how to find that variance of the sampling distribution of the sample mean. Your population standard deviation is 290 and you're drawing a sample size of 1,000. You want to find out what is the variance of the sampling distribution of the sample mean. Well, that is going to be your standard deviation squared, 290 squared, divided by your sample size of 1,000. That equals 84.1. If we increase this sample size to 10,000, our variance is going to drop to 8.41. That's how to calculate the variance of the sampling distribution of the sample mean. Visit us at statisticshowto.com for more tips and videos on elementary statistics and AP statistics.